All right. Welcome to Boyle's Law and the Combined Gas Law, Unit 14.4. So we'll start off with Boyle's Law. Yesterday, we took a look at pressure versus temperature and volume versus temperature. Boyle's Law deals with pressure and volume. And Boyle's Law states that pressure and volume of a gas are inversely proportional to one another. So inversely means that as one goes up, the other goes down. So this is the one law where the relationship is inverse. Both pressure and temperature and temperature and volume were both directly related. As one went up, the other went up. But with pressure and volume, as one goes up, the other goes down. So an example, nitrous oxide is used as an anesthetic. The pressure on 2.5 liters of nitrous oxide changes from 105 kilopascals to 40.5 kilopascals. Assuming the temperature does not change, what will the new volume be? Again, I like to list up my variables. My first volume was 2.5 liters. I'm looking for the second volume, the new volume, question mark. My first pressure was 105 kilopascals, and my second pressure was 40.5 kilopascals. Again, the first step to these types of problems is think it through. Did the pressure go up or down? The pressure started at 105 and went down to 40.5 kilopascals. So what's the nature of the law? Inverse relationship. So if pressure went down, we're going to expect the volume to go up. All right, let's set up our factor label. We're looking for a new volume, so question mark liters, we're starting with 2.5 liters. Now again, if I want my number to get larger, and again I do, I've got the arrow over here, I want this volume, the volume to go up, I want to put the larger of the two values on top. 105 is larger than 40.5, so we'll put the 105 on top, the 40.5 on the bottom. And compute. Our new volume is 6.48 liters. Another example, a gas with a volume of 4 liters at a pressure of 205 kilopascals is allowed to expand to a volume of 12 liters. What is the pressure in the container if the temperature remains constant? Again, I like to list out my variables. My first volume, gas with a volume of 4 liters, so there's that, is allowed to increase to a size of 12 liters. So there's my second volume. My initial pressure was 205 kilopascals. I'm looking for my second pressure, P2. Again, we have to think this through. Volume went up from 4 liters to 12 liters. So we're going to expect our pressure to go down. Inverse relationship. I'm going to set up my factor label, question mark, kilopascals is equal to 205 kilopascals. And now I want a ratio that's going to give me a smaller number. If I want a smaller number, that means I want the smaller number on top and the larger number on the bottom. So 4 goes on top, 12 on bottom, 205 times 4 divided by 12, 68.3 kilopascals will be our new pressure. All right, this brings us to the combined gas law. Exactly like it states, the combined gas law combines all of the gas laws we've so far talked about, Boyle's, Gay-Lussac's, and Charles's. So if you're ever working with pressure, temperature, and volume, you're probably working with the combined gas law. It doesn't matter which order you solve each of these problems in. So for example, a gas at 155 kilopascals and 25 degrees Celsius has an initial volume of 1 liter. The pressure of the gas increases to 605 kilopascals as the temperature is raised to 125 degrees Celsius. What is the new volume? Okay, again, guys, I cannot recommend this enough. List out your variables. My initial pressure was 155 kilopascals. My second pressure was 605 kilopascals. We increased to 605 kilopascals. My initial volume was 1 liter. We're asking for the second volume, my new volume. And then my temperature, don't forget to convert to Kelvin. Always convert to Kelvin. So my initial temperature was 25 degrees Celsius. I convert that to 298 Kelvin. My second temperature was 125 degrees Celsius. I convert that to 398 Kelvin. All right, we're looking for a volume. It's going to be a factor label problem. And again, it doesn't matter which order we go through. Let's see here. I'm going to do the exact same steps I have been doing. My pressure went up from 155 to 605. Think about the relationship of pressure to volume. That's an inverse relationship, Boyle's law. So I want my volume to go down if the pressure went up. That means I want the smaller number on top. So that's going to be 155 kilopascals over 605 kilopascals. Next, I'll take a look at the temperature. My temperature went up from 298 to 398 Kelvin. Again, we have to think about it. T and V, that's Charles's law. That's a direct relation. That's a direct relationship. So as my second temperature goes up, I want my volume to go up. So this time I want the larger of the two values to be on top. So 398 goes on top, 298 on the bottom. Now all I have left to do is to multiply 1 times 55 times 155 times 398 divided by 605 divided by 298. We'll come up with 0.342 liters. Another example. A 5-liter air sample has a pressure of 107 kilopascals at a temperature of negative 50 degrees Celsius. If the temperature is raised to 102 degrees Celsius and the volume expands to 7 liters, what will the new pressure be? Again, list out your variables. I cannot emphasize this enough. Your first volume was 5 liters, 5-liter air sample. It expands to 7 liters. That's your second volume. My first pressure was 107 kilopascals. They're asking for the new pressure. What will the new pressure be? So P2, unknown. My first temperature was negative 50 degrees Celsius. So I want to add 273 to get to Kelvin. My second temperature was 102 degrees Celsius. Again, add 273 to get to Kelvin and set up our factor label. We're looking for kilopascals. We're starting with 107 kilopascals. Again, it doesn't matter where you start. If you want to start with temperature, you can go for it. I started with volume. My volume went up. It's an inverse relationship between volume and pressure, so I'm going to expect my pressure to go down. So I want the smaller of the two volumes on top, 5 over 7. And now we'll take a look at temperature. My temperature went up, so I'm going to expect my pressure to go up. That's a direct relationship. So I want to put the larger of the two numbers on top, 375. It's on top, 223 on bottom. And now all that I have left to do is multiply across the top, 107 times 5 times 375, and divide the bottom, 7 divided by 223. And I'm going to come up with a new pressure of 129 kilopascals. Hey, all it takes is practice, and here is some practice for you. Homework for this evening, homework 14.4, due tomorrow.